Good morning, Willow. How are you doing? I want to tell you a little bit of story about Willow. If you wonder why she's not bouncing all around the yard, you know, a lot of Chihuahuas are energetic, and she's a long-haired Chihuahua. And Willow was born with a deformity to this leg right here. Her bones are not right, and it makes her patella slide off the side of her leg, so when she walks she kind of flops around. She's had 2 surgeries on her left knee, and they've made a little groove in there to try to keep that patella in place. But she's energetic at heart, but she just can't move around a lot. She can't jump up and down. I have to lift her up and down off the couch and stuff. She's unlike other dogs that can jump up and down. She can't do that. The other problem Willow's got is she's like me. She's getting old. She's 12 going on 13 years old. So, you know, we don't move around as much when we get older, but she's still just a sweet dog. She helps so much. She got her name by being a shop dog. My wife had her business on the bypass for a long time, and we finally moved it into our studio for her. But while Willow was there, she was our shop dog, and Willow got named after our store, Twisted Willow Studio, and that's how Willow got her name. We had a shop dog prior to Willow. That shop dog's name was Molly. It wasn't our dog. It was a dog of one of my wife's customers, and my wife let her hang out the shop while the customer was at work. She needed a babysitter, and we babysat Molly for a long time. One day Molly had a stroke there in the shop, and we lost Molly, but right after that we got Willow, and Willow is our dog. She's a new shop dog, and now she is a shop dog here in my wife's studio. But Willow, she's going to help me with radios today. We're going to continue on with our series, and she is so smart when it comes to radios. She's been hanging out with Dad all these years. She knows her stuff. All right, we'll see you in a little bit. We'll start our series again. Well, hello, welcome to Radio Hound Tube Radio Restorations. I'm John from Indiana, and this will be probably, I think, part 10 in our series that we've started on this learning how to work on an old antique tube radio for beginners. We're in the schematic part right now, and I'm going to be doing several next videos on making sure that you have a good understanding of schematics before we actually get our hands on inside the radio. So that'll be nice. I'm always so hard on myself. When I first started this, I hated to hear my voice, and I've been judging myself real hard when I do certain things wrong because I'm still making rookie mistakes. But bottom line, I'm not going to quit. I'm going to quit being so hard on myself and just try to make the corrections and try to do better on the next video. The last video kind of bothered me a little bit because I had this great idea in my head on how I could get that across to you and how the power supply worked. And I feel like it was a little disjointed when I videoed it, but I think overall you'll get the gist. The big thing that I wanted for you guys to understand is I wanted for you to understand, and the main takeaway is power goes into transformer AC, and it comes out the rectifier as rectified DC, and I just wanted you to know where that came out at. It comes out at the cathode on the rectifier, and that's where you're going to see those volts DC on that cathode line. That comes off if you have twin rectifiers or single rectifiers, it's just going to come off of one line coming out of the rectifier area, and that's where we're going to kind of pick up on today's video. Today's video we're going to go over a couple of the schematic images so you don't get lost in there. Now, most people know what some of these are, but just in case there's somebody out there that don't, I'm just going to go over a couple of them. I'm not going to go over all of them because there's a bunch, but I'm going to go over the main ones you're going to run into. And then I'm also going to talk a little bit in this video about the wiring, just to get a few concepts behind you so you can understand. Matter of fact, that's the main goal of this video, is for you to understand how the wiring it looks versus how it looks in a schematic, because sometimes that was a big hang up for me until I understood that. And I'll be honest with you, Mr. John from Arkansas is who this YouTube channel is in honor of, and he's the one that helped me to see this particular piece I'm getting ready to bring to you. I hope that I can do him justice and try to help you understand it too, and it makes me feel really good if somebody walks away and say, oh, okay, I understand now how that's working. But at least I'm going to start bumping on it right now. Today we're gonna introduce you to it, and that way as we go through this radio, I'm going to say a lot of this stuff 100 times, so you're going to finally get it. But it's just I would love for you to get it up front, because it's a lot funner than to do the next steps and stuff. But the things that we've learned so far is we've looked at the radio, and we have the parts, physical parts that you're looking at on the radio, and then we went to the schematic, and you got to look at what the schematic diagram of that part is, what it kind of looks like, and roughly on most models roughly where it's at on the schematic page. And we went over that, so that's the first thing we taught. And then we went in and looked at the power supply, and we kind of went over how that transformer looks on paper, and how that power supply produces your volts DC that you're going to need later on in the radio, and you'll understand why later on why you need that. That provides a lot of voltages all the way through the radio, not just the place it gives you voltages elsewhere too. So we've learned that so far. Now we're doing the next step, is how to maneuver through that schematic, because all these parts. I also showed you the different sections of the radio on the schematic, and we're going to see how that high voltage that comes out of that rectifier, how that gets to those different sections of that radio. And so we're going to try to hit on that today. If I don't get it all done in this video, we'll continue in the next video, but I think we'll get it all done. It's not that hard, but it's just a main concept that we want to learn. All right, well, I'm looking forward to seeing you there, and we'll get started. Thank you. All right, when we left the last video, we were going over this power supply right here, and I kind of showed you how you went from AC right here coming in from the wall, and we rectified it through this transformer and these two rectifier tubes, the 6X5Gs, and I taught you how end result, and like I say, I really don't care if you remember how it happens, but what happens is you end up with your volts DC on this line. This is your cathode. I've been referring to it as the frying pan because I want you to understand there's a fire here, and that's a frying pan, and this fire is heating that frying pan up and boiling the stuff off to these plates over here. But bottom line is we got to start learning the right terminology. That is a cathode. And then these plates are the anode. Okay, they're called the anode. So the cathode is where that voltage comes out. So you're going to have that voltage, and we don't know exactly what our voltage is going to be yet, because we don't know what this is going to produce as far as how many volts AC. Remember, in my sample we just did 600 volts AC, but it might be more or might be less. I have a feeling it's going to be a little bit more. It's probably going to be about 670 volts across here. So, you know, we're going to have about half of that in our DC voltage sitting on this line coming right out there. And I'll get maybe a little closer. I don't know if I can focus, but that's the line that shows that voltage. So today's video, we're going to pick up right here where that line is, right here coming out of this cathode off of this line right here. All right, so we're right here. Our voltage is right here. The first thing you run into, because the way these schematics work, when you see a little dot like that, there's other things hooked to that. So if you see the little dot, and I don't know if I can get in close enough because this thing's not focusing right, but Oh well. Anyway, there's a dot right here at that connection, right there, and that means other things are hooked, and so that means that right there is hooked to it, and then whatever this is hooked to it. Well, we mentioned this in previous videos that this is your field coil. All right, the field coil does not set in the radio; it sets out in the speaker. Sorry. But the field coil sits, let me get a speaker over here and I'll show you. The field coil sits right here in the speaker. All right. So that's what's connected. So we know coming straight out of our rectifier, we need to be able to connect our field coil. The other thing that's connected right here is this is a capacitor. This one says it's C17. And let me see, I don't know if I can zoom in that way maybe. Yeah, that's better. Okay, C17 is probably an electrolytic capacitor because I said most of the time the first capacitors you're going to run into are your electrolytics because they're filtering that DC that's still got the positive humps, but it's still got that little gap in between the humps, and that's what this guy does. It's a filter capacitor or electrolytic capacitor. Okay, so it's filtering that out. All right. So what we have to do is we go look at C17. Well, down here on most of the Zeniths, you have these parts listing. And if we look at C17 right here, it says a 20 microfarad electrolytic. So that tells you the value of it. And we'll study on microfarads later on. But basically, anytime you have more, like see where these all have decimal in front of them. If there's not a decimal in front of them, the decimal's behind it, then it's usually an electrolytic, okay? But we know that C17 is an electrolytic. What that did is just told us it's electrolytic. So there's two things hooked so far to our wire. And then to understand how to read these schematics, you know there's not something else hooked to this wire because you got to get past that thing and you got to get past that thing to have any more of these dots connected, okay? So we only know that we're going to see two things. Now, look at the distance, and this is the main point that I want you guys to see. Is my arm getting tired of holding it. The main point that I want you to see in this whole video today is look at the distance between, I got this zoomed in and it's making it shaky. The distance, maybe I can do this left-handed. I'll learn how to do this, y'all. But the distance between that dot and that field coil is not very long. Look, that's maybe a 1/4 inch on the schematic. Well, let's go look at it in real life in here. And this is one thing that took me a long time to figure out. I'm thinking, well, that thing's got to be real close. That field coil's got to be real close to where that my rectifier tubes are. Well, what we're going to do is we're going to go inside the radio here. I may have to unzoom this a little bit to be able to keep it steady. If you look, you've got your filament pins. Remember, we got two rectifiers, so you got your filament pins down here on this one, and then you got up here, it's a mirror image, so I got to move that wire out of the way. Let me get over here. Okay, this is your filament pins on the other rectifier tube. Now, off of these filament pins, the only thing they're going to, and that wire is right in my way. All right, these filament pins right here, see that filament right there. All right, the only place that wire is going to is the other tube. But when you look at the other tube in that area, there is a wire coming off of there. All right, and I know there's a lot of stuff in here blocking you to see it, but there is a wire, and that's this wire right here, okay? So that wire is coming off of that filament pin, and it's the only wire coming off of the filament pins, the only ones coming off the filament pins, and that's the filament pins is also your cathode on this on this type of rectifier on 6X5. So this, we're going to call it our cathode from now on, not our filament, because it does do a job of a filament, but it also does the job as the cathode. Well, when I said our voltage comes off, so there's only one wire coming off, and that's what you'll find on all these rectifiers. There's only one wire coming off of these, And look at this. We're gonna follow this wire. It goes up here, up here, up here, curls around a little bit, goes up here, and goes clear up to this top end of this radio. Well, wait a minute. It's supposed to be that thing's supposed to be clear down here by the right next to the rectifier tubes, but it's not. And this is what you're going to find in these old radios. You're going to find this a lot. Is this filament wire that holds 300 and some volts coming out of those rectifier tubes is probably not going to be right next to that. And I tell you why, because it's out here on the speaker and it has to come out of this radio somewhere. So there's going to be a plug back here somewhere, or some kind of direct wires coming out of here that goes out to your speaker, because most of the time your field coil is going to be out here on the speaker because it has a job. It has a job to energize this voice coil to make your speaker work. It has other jobs too, but that's a job for it. So even though you see it right here, you see it here, right next to these two rectifier tubes, the distance on these schematics is not, don't get caught up in the distance between these dots, between that dot and that item. The reason they're showing that here is because the field coil has another function too. It has multiple functions, but it does a filtering job. It also does another function, is it's going to drop voltage. So let's just say, for whatever reason, that our voltage coming out of here is 350 volts. And I'm going to try to get something to write here. All right, let's say that's 350 volts coming off that line. So let's say there's 350 volts coming off of that cathode, off that rectifier, and it's going up to here, and it's going to this plug, okay? And then the plug goes out to the plug that goes to the speaker, and that plug goes into the field coil, and then it comes back out of the field coil and comes back to the plug, all right? And then it goes somewhere, okay? And that's here on the other side of the field coil, okay? But let's just say it's going to cross through that field coil. So when you run electricity through that field coil, what do you think is going to happen here? Yes, most of you got it. The voltage is going to be less coming back. So in other words, you're going to have, say, 350 here. You might have, and I'm just hypothetical here, you might have 275 volts. We'll get the actual numbers here when we get this thing recapped and fired up. But at that dot right there, you might only have 275 volts. Now, why would that be important? Why would you need this help right here? Well, number one, we have to start at a number, and then we use these types of coils, and we use other types of things to drop voltages, because some of these tubes operate under different voltages on these plates. Now, if you'll follow this wire right up here, and I'll talk about the next dot here in a minute, but let's just pretend, this is a continuous wire that goes up here, and now this is going out to the speaker right here, okay? And then that's when you see this part on the speaker. And my page cut off when I printed this, but it shows the actual cone like a speaker out here on the side on the actual schematic. This particular printing job is not good because I didn't catch the right side of the schematic. But this coil right here, you always have the field coil, and then you'll have this coil. That is this thing right here. And this transformer is called an output transformer. And what it does is it interfaces your output tubes, which usually sit right up in here, right close to this speaker plug. But it interfaces the output tubes to the voice coil, because what you have to do is you have to have, and I'm going to go into that in depth, so I'm not going to go too deep, but basically you have to have an impedance matching between your voice coil, which is only 8 ohms or 4 ohms or whatever ohms it is, and then you got to match it to the impedance that comes off of these output tubes, which a lot of times is, you know, for like a pair, like I've got a pair on this radio. See, I'll go over that later too, but there's 2 output tubes here. Well, if you have a pair you're going to have like maybe 7,000 to 8,000 ohms. So you have to make those two, excuse me, make those two things talk to each other. If you don't, you're going to burn something up. So that's what this output transformer does, is it transforms the impedance so you don't damage your voice coil, or you don't damage the tubes, because it can go both ways, and it can send it can run these tubes too hot, and then they'll burn your tubes up. So that's what this output transformer. But see, our line goes straight up to this output transformer. And if you want to see how that voltage gets, that 275 volts hypothetically gets up here, it goes in through the center tap of that. There you'll see there's like 3 wires over here going in. There's 3 wires going into that. Well, that's your center tap is where your high voltage goes into, the 275, and then it goes through another half a coil to get to this plate. And that's how this plate gets its power. Well, let's say it'll step it down another little bit, and it might be 250 up here, okay? So, can't write through this camera. Okay, so let's just pretend that that's 250. So this half of this winding on this output transformer helps to step that down a little bit. And guess what? You know, like 6V6, you can look it up in the book. That's the output tube. And you can look up what the plate voltage should be, and it might be 250. But they've already figured this out on these coils to figure out what it would take to step down whatever voltage you got here coming out to the right voltage that you need at that plate right here. And that's the point I was trying to make here, is that's what this field coil is doing. So they put it down here on paper by these rectifier tubes to know that, number one, you need that field coil in here to help control that voltage coming out of here. It not only does that, but it does the magnetism for the voice coil down here. But it's doing 2 functions, and they if they drew it up here, it would confuse you because you didn't think something was happening down here, and it is. First thing it's doing is stepping that voltage down and helping filter. So here we got a filtering going on here. It's taking some of those ripples out, like I drew the picture of on the last video. I think I got a picture of that here. Might as well get it on here. Like where we have all the positive humps coming out at 300 volts DC, and it takes out this gap, the gap that's right in the middle here. That little battery, the electrolytic, is filling this gap, and when this voltage goes down here, it don't allow the voltage to go down because it uses that battery, and it keeps that voltage up where it needs to be. And then when this voltage comes back up, it recharges that battery, and it's charged up the next time when you get to the next gap. Now this happens at very, very high speed, so you're not really paying attention to that happen. But the better electrolytics and getting the good electrolytics in there, that'll help that ripple, and you're not going to hear that hum that you always hear when you plug in one of these old radios when you're not supposed to. All right, so the next thing, you know, when you're coming off of here, we get on the other side of that field coil. So when we're coming back on the line on this field coil and back in through the plug, and we get back inside the radio, then the next place we're going to go to is a secondary electrolytic, okay? And that's going to be another electrolytic. And if you looked up this one, it's a C18, and we go in here to C18, and it says it's another 20 microfarad electrolytic right there. All right, so when you come back in the radio, you're going to have, and let's see if I can find the right plug. Well, we'll do it when I'm a little more prepared, but bottom line is it's going to come back in the radio to another electrolytic. Now, here's the question for you. How can you tell where your electrolytics are in the radio, okay? The easy way, and how I like to do it, is just look on top, okay? This is for beginners here. When you look on top, and we're looking for electrolytics. Oh my goodness, where are they? Normally you have a silver shaft on top that holds your electrolytics. All right, so where are our electrolytics? Well, when I come back, we're going to try to go over that part of it. Because normally you will have a silver can like we did on our practice radio, and you have a silver can on there. But on like, there it is, like that one right here. I don't know if I can get it. That one is what you're looking for, and you would go underneath then, right underneath that, and that'd be where your electrolytics was. But on this one, I don't see a silver can. So where is our electrolytics? So that's the next thing we're going to do, is try to find that. Sorry about all the moving around. All right, we're coming back. Thought I'd just take you a few minutes to try to guess where these are. All right, now we know we got two 20 microfarad electrolytics hidden in here somewhere. Well, the first thing you're going to do is, if you can't find one on top, then it's going to be underneath this cabinet somewhere, okay? And if it's underneath this cabinet, it's going to be probably one that looks kind of what we call these waxies. They're coated in wax, okay? And because we're coming out of this era, and especially in the zenith, you're going to find waxies. Well, the next thing you do is, if you can't find one of those silver cans on top, and then, like, if you were to find a silver can, you'd just come underneath and you'd see the bottom of it right here. But on this particular model, they've got theirs underneath, and it's going to be the largest one of these. It's going to be a big one, because, you know, that's pretty high voltage, and it's going to have to hold some voltage. Well, where's our big ones at? Let's see. Those are pretty good size right there. That one's a good size. Those are pretty good, but I bet there's bigger. Oh, look down there. Now, see, that's a coil right there, but there's one of those right there. What they've done is they've tucked that in on the bottom of the radio, and you can see there's a metal frame that hooks to the chassis right there, and it's got a strap around it. Well, I hope the purists don't get mad at me here, but the first thing I do is I cut that loose. Sometimes I'll leave that strap hanging out there and use it for a grounding point for other things, but some of the purists, they like to cut the end of this off and restuff it, and then put wax back in there and make it look just like it never went away. I don't mind if you do that, and you can do that, and I'm not condemning anybody that does that. I just don't do that, and I will cut that strap and pull that thing right out of here. But I'm not going to disconnect it. I'm just going to pull it out to where we can see where those wires are going, okay? So what we're going to do is we're going to do that. I'm going to get it freed out here, and I'll pull it out here where we can get a better look at it. But ours is tucked back in there, hiding in behind that coil right there. So we're going to get it out here, and that way we can see where those wires go. Because you need to know, this is one of the first things we want to fix, because we don't want to apply any power to this thing until we know that we have our electrolytics fixed, because that's what burns stuff up if we don't have that fixed. So I'm gonna pull that out here, and then we'll start again here. All right, here we are. This is our electrolytics, and they have, as you can, here's the best way to tell on this. I don't know if I can get that turned around a little bit. Look how many wires is coming out of here, okay? One of these is going to be your ground, and the other two are going to be each of your electrolytics, because they have more than one electrolytic in here. All right, and I know these things are dirty, and that's why my room's so dirty. It's not because I'm a dirty person, it's just these radios are very dirty. But if you wipe this off, it should say, and I got to find the spot that it's saying it at, but it should tell you what's in here, okay? And we'll find it out here. Okay, there we are. The yellow wire, it says the yellow is 20 microfarad at 350 volts DC. And then the red wire is our 20 microfarad at I think that says 450 volts DC. And you can wash these and you can get them cleared up. And it's just wax coating, so you can actually scrape a lot of that and it'll come off enough to where you can really see that good. All right, so we know our red wire is the 450 and our yellow wire is the 350. Now I replaced these with 630 volts. This is the wrong microfarad, but I either do 455 or 6, but as long as you do above what they have listed here, don't go crazy above it, but you can do above it. The reason you don't go crazy above it, because when you fire this radio up, it has to fill these capacitors up. You're like charging a battery. Well, if you have a bunch of extra voltage there above that, it's going to shoot that extra current to fill all these batteries that's in this radio. When you first turn it on. Now you have what they call a surge current. You don't want that surge current to be too much, but you don't, you can actually go 600 some volts on here and it's not going to hurt a thing. But make sure, the main thing is to do at least the 20 microfarad. You can go a little bit more on that too, but it's not going to hurt a thing to go over that, the 20 microfarad. Don't go under it. You need to stay at least 20 microfarad, and you need to at least stay the 450, and you can go a little bit above either one of them. All right, but bottom line, I found my electrolytics. So that's these two little guys right here. These two guys on either side of that field coil is right here. So let's trace these wires real quick. Well, the first one is right here on the rectifier itself, because if you think about it, this is another one of those things where you think, well, wait a minute, that electrolytic sits clear up here. It's not even down on it. There's a wire in between there. No, it's the same point. That dot right there is the same dot as that dot, because there's nothing between them. And that's something you got to learn about these schematics. If there's a dot here and there's a dot here and there's nothing between them, those two wires can actually be connected directly to each other, because there's no resistor, there's no anything in between. So the bottom line is those two wires could be directly connected. That point, that dot right there, could be sitting right on top of that dot. And that's exactly what they did here, because this is your red wire. All right, and it's connected straight to the filament, straight to it. And so that means that electrolytic is actually not here where it's drawn, but it's actually down here where it connects. And you just have to wrap your head around it. The biggest thing to remember on this is if you have a dot here, boy, this thing is fading in and out. Let me try this way. All right, see, I got a dot right here and I got a dot right here, but those dots could be connected at exactly the same spot. That line might not even be there. This could be right down here. And anywhere on this schematic, if you see it, just a straight line between two dots, those two dots may be directly connected. This wire right here is coming in right here, may be actually connected right here. So if you don't see anything in between the two dots, always look to see if they're connected directly. This is your candom that I pointed out up here. All right, so that wire, find my spot back here again. That wire that's coming in there could be, this wire right here could be directly hooked to the end of the candle. It doesn't hurt a thing to have a hook right there, but they have to spread it apart here to make it lay out on the paper right. And you just got to wrap your head around it, and that's the one rule you got to have in your head. If you see two dots with nothing in between them, no part in between them. Like, see, this has a part. This little zigzag line is a resistor. Anytime you see a zigzag line, it's a type of resistor. It could be any kind of type of resistor, but it's a type of resistor, okay? And that's one of the parts. If you see two lines that are separated by a gap, now one line might have a little curve on it. I'll explain those later, but if there's a gap in between, that means it's a capacitor. And on Zenith models, all the capacitors will start with a C, and then the resistors will start with an R, and that's how they list them down here. On here, all the capacitors will be on this side here with a C, and then usually your resistors over here on the other side with the R. And the main thing about that is when you look it up down here, it gives you the values and everything. It's very handy. Now, a lot of other models, they'll put this page, it'll be a whole separate page, and it's actually, sometimes having it on this one page is kind of aggravating, because I mean, it's nice and handy because it's on the same page, but it makes the schematic a lot smaller. And if they move it to a second page, you get a whole page of the parts, and then the whole page of your schematic, and it makes things bigger for an old guy like me. Makes it see better. Okay, so we figured out where that capacitor went. Now we got a ground in here, we know. Okay, so we got to find out where our ground is. Okay, one of these other two wires is going to ground, right? So if you was to trace this around, and it might take you a minute, but you can trace these wires and see which one actually touching ground. And one of them is, and I will tell you, I'm not going to do that on this video, but because it gets a little confusing, because you think, well, it's going to that's a little terminal strip there, it's going to the end of that. But eventually, that goes to ground, okay? And if you'll look at these, what happens here, see, this is the positive end because it's our high voltage on this end. So this is your negative end of that. So that's that black wire coming out of that capacitor. Well, it don't go straight to ground, because it goes to the other capacitor, and at the grounding end of the other capacitor, and which, by the way, they're both already connected inside this thing here. So the positives go in. Anytime you see the colored wires, they're going in, and the black wire is going out. Okay, so that'll help you remember that. But anyway, the black wire, it's going up here, and hey, looky here, it runs into a resistor, then it runs into the candom resistor, and then it runs up here, and then it comes over here, and it goes through a capacitor, and it goes back to the candom, and it goes to ground finally here. All right, so this negative side goes through a lot of things, and that's why I'm saying I'm not going to do it on this video. But and this is the black wire. I know you can't tell it in this camera, but this is your red wire, this is your black wire, and that's your yellow wire. If I was to scrape it off, you'd see the yellow color. But that black wire goes to a lot of places. It goes this terminal strip, and it jumps all the way through. It goes all the way up in here, all the way up the top part of this radio and whatever. And even though it don't look like it goes very far down here, it goes a long way. So this little wire, that's the other thing the second concept I want you to get, is that wire shows that distance right there, but that wire may end up taking you physically to the other side of the radio, and then coming right back to this point here. There's reasons they do that. It's above my pay grade as how that happens or why it happens. But bottom line is, don't just go off in your mind off the distance that this is. That could be right touching each other, or they could be a wire that's 4 feet long. I'm not kidding. Some of these I've seen stripped around and wrapped around stuff, and it's unreal, the distance, when you think it's just a little short hop and skip and a jump between here and here, and it may be clear physically, you know, it may be from down here, it may be clear up in that right corner. A lot of times, and I don't want to get into this either really, but I'm just going to say that a lot of times, like electrolytics, they'll have the electrolytics at the opening gate where you come in and filter, but they'll actually put the electrolytic, they'll put them up in a far corner somewhere away from, so it won't create a bunch of noise on the audio. So your electrolytic, I got on that pilot radio, I just set the thing on the floor, but they have one just like that. There was 4 electrolytics, and they have them clear up in this top right corner because it's space, number one, and the other thing is it's a safe place for noise. And I will tell you this, if you're ever changing out these electrolytics, always put them back in the vicinity where they had that. They have this locked right there, the one that I pulled out of here. It's in that spot right there. Well, I'm going to put my terminal strip right close to that area because there's a reason they put that down here. It's engineered, and you don't want to take this electrolytic, because I can physically put that anywhere I want it and still end up with the end wires where they are. But the bottom line is, you don't want to do that, because you might be creating noise in your radio. and you really mess up your sound. You think, man, where is that noise coming from? It's like static, and it's a bunch of interference in my radio. What's going on? Because you put your electrolytic in a different spot than they had it. So you always want to put your replacement electrolytic, you want to put that back in close, just in the, I could put it right here. I put a terminal strip over here and then put my electrolytics and I'll be fine. All right. So the concept that I want you to walk away with today, and we're going to get deeper into this, but I wanted you to understand, if you have two dots with nothing between them, that line could be way far apart in the radio, or that line could actually be not even there, and those two dots could be right on top of each other, and that would help you to maybe understand that concept. Okay. There's only other thing I mentioned in my introduction is that, you know, maybe understanding just a few of these little symbols in here. I already went over the resistor one and the capacitor one, and that's a ton of what you need right now. It's just, you know, this is a radio full of a lot of resistors and capacitors. So when I did the other introduction to what the parts look like versus what they look like inside, these are always the symbol for the switch wafers, and this is all the same switch. They just break each wafer at each side of the wafer. They break those down, so it's just this one switch assembly in here. But there's a wafer here and it has two sides. There's a wafer there that has two sides, and there's another one, and they just break those apart. And see, those are all together physically, but they're spread apart on the schematic in different spots because they have to draw it out to where you can see what those wafers all do. And that's what's confusing to people a lot. But if you just stay on your line when you're traveling and you look at it, just whatever's next is what you're going to run into. Now that dot, like say, okay, there's a dot right here. That dot is way down here. But this wire may actually be hooked right onto that pin right there on that radio, and it probably is on that tube. That tube pin probably has that wire right there hooked onto it, but they spread it out so you can see what's happening in there. You continue on down. Next thing, there's nothing to run into yet except for that resistor. I'm not going to run into anything else until I cross over that resistor. So I can find that resistor, and then it could help me trace. But here's one more tidbit that I want to take away on this video, is you get lost in here, and it's easy to get lost. But if you get lost and you're tracing, and you know you're up in the radio and you're trying to trace where you get, I am totally confused. Find you a known spot, and the known spots, the easiest known spots to find, are the tubes themselves. Okay, the tube is a place that can get you reoriented. Okay, zenith is real easy because remember on top, on the tubes on top, you have your tube name right there. This is a 6V6, so I know the name of my tube now. So I can go back up in here, and I know that top corner tube up there, if I can get my camera right, is a 6V6, okay? And remember I told you how to count pins from the little slot? You count to the right clockwise on the bottom. If you're on the bottom of the radio, you count clockwise. So that's pin 1, pin 2, pin 3, pin 4. Okay, so I can tell that what my pin numbers are because I can tell by that. Now, remember I told you how to go to the book, the 6V6, and we would go in here in our RCA manual, and we would pull up a 6V6. These are numerical order, and looky there, is 6V6. Well, it shows just like on my schematic, but it tells me what my pin numbers are. So that's pin number 3 that's my plate, that's my anode. Okay, and then I'll explain these later on. These are called grids, and there's different kinds of grids. There's I'll go over them later. I really want to go over them now. Right now, what I've been discussing to you is what they call a triode. You just have the heater as your filament, and this is your heater, and this is your pan, and it's called the cathode. And I had a heater, the cathode, and and the plate or the anode. And that is really all you need to know right now. I'll explain what the grid does later. Each grid has a different function, but some of these only have one grid, some of them have no grids. If you have just the heater and the cathode and the anode, that's called a triode. That's the name of the tube. It's a triode tube. It only has 3 parts. And that's what we're going to deal with just technically right now with a triode. But if you get lost, okay, we know that our cathode is pin 8. Now let's go back to 6V6 over here and I get lost. Then I know that my cathode is pin 8. And I'm going to try to get dialed in here. Okay, so what I do, or I don't do it anymore, but I did when I first started out, is I go in here and I write 8 beside my cathode. That way from now on, I know I can count to pin 8, and I know that that's the wire coming off of that, okay? And then I know that the anode is pin 3, so I can go up here by this wire, and this is my plate right here, so I can write 3 there, okay? All right, and then, like I say, this particular model has grids, and I'll have to explain those to you when we get into that, but right now I'm just dealing with the triode part. And then my my filament, I don't usually label those, but if you need to label them, the filament on this one is pins 2 and 7, so you can put, get in the right spot here, you can put one side being 2 and one side being 7. It's probably the other way around. I did that backwards, but bottom line is, and you can label all these numbers, okay, just for the fun of it, since we got the grids here. So this is 3, 5. So this center one, this one is, sorry, I got my hand in the way. The center one is 5, or the bottom one is 5, and then this one is 3, and that's for the grid lines right here. So you can pre-label this on your schematic. So then when you're trying to reference that wire, okay, I'm trying to find a wire that's going out here to this isolation transformer, okay? So I'm looking at pin 3 on my 6V6, so I can go up here and I can count 3 pins up. Let me get lined up here. I can count up 3 pins. Remember the slot right there? I go 1, 2, 3. So this is my wire going out to my output transformer. So it's my blue wire coming off here and following the blue wire. And guess what? It goes to the plug right here, to that pin right there, all right? And then I go out here to my plug, and sure enough, that's where it comes out. Well, guess what? That's what goes out. That plug goes out to this output transformer right here. And so you know that you got the right spot. You've oriented yourself, and you figured out, okay, I'm right here, and that's going out there, so that wire is fine, except for this wire is going to have to be replaced because it's a rubber wire, see how it's cracking, so we're going to have to put a new wire in there. The bottom line is that if you get lost, go to the tube, go to whichever tube in the area you're working on. Like say you're out here and you're working on this area right here, and you're, man, I don't know where I'm at. Go to the tube and work backwards and try to get back down to the area you were at. And basically you just follow in that wire, okay? And I'm coming off this plate at the 6F5. I have 2 things that should be there on that, and it might be directly connected to that pin, okay? And even though it's showing it out here in midair, it's probably connected on that pin, okay? So there's 2 things. I should have 2 wires coming off of that pin number. And then I trace one wire down that way and one wire that way, and run into the first thing you run into is a resistor out here. And the first thing you run this way is, I think there's a dot there, I can't tell on this camera, but there would be another resistor here. So you're going to make sure that those are connected right, and kind of work your way through. Then the other thing I do, and this will be the last thing I say, and I'll just recap, is I use highlighters, and as I check an area, I will highlight that wire. I say, okay, just like yesterday, and we've already done this on a previous video, but I've already checked all these windings on this, so I can highlight, and I know that I've got good continuity on the wiring, I've already checked my switch. I know my switch is good. I'm not going to mark my capacitor because that's got to be changed out. All right, and then I marked this because we checked our filaments on a previous video, and we checked the high voltage winding on a previous video. We checked that winding, checked that, and we also checked our filament winding. All right, so the bottom line is that's how we're doing. So I'll wrap up here in a second. Just to wrap up now, the big things I wanted you to get today is if you have a wire dot and a dot and nothing in between those dots on a string of wire, then those dots could be totally connected to each other, and this item could be totally connected clear over here. All these items that are on some of these strings where there's nothing in that line, they all could be literally connected clear over here somewhere. The other thing that you have to get in your mind is that also could be spread apart further too. If you have nothing in between, that distance could be far apart or close together. So you got to keep your mind open to that. Also, parts like as in the example of the switch, you know, that's all in one switch, but they break all the parts open so you can see them on there, and that way you can tell where all the wires are connected on each wafer. So your part may not be physically setting where you think it is. All right, that's it for today. Thank you very much. Well, I hope you enjoyed today's video. We went over a few things today, but the main takeaway is on how the power maneuvers through that radio and how the different parts are connected together, and kind of how to understand that when you're looking at that schematic versus looking at the real radio. So next video we'll probably go into a little more depth on the breakdown of voltages as they move through that radio, so you kind of see how each area gets its own voltage, and basically what we're still doing when that radio comes out of there, when that voltage comes out of that rectifier, that's 250 to 300 to 350 volts DC, and what we're looking at is the power supply. They call that the B plus rail, and that when you hear people refer to B plus, that's where that comes out there at that, and that's the B plus, and we're going to follow that B plus through the radio and see what happens to it as it moves through the radio and feeds to your different tubes and your different areas of the radio. That'll probably be the next video that we break down on that. All right, thank you for watching today.